The universe is a place full of mysteries. Among the many strange objects that exist in space, some are so bizarre that they defy logic. One of the most impressive is the magnetar. It's small, but extremely powerful. Its magnetic field is the strongest in the known universe. Even though it's thousands of light years away from Earth, a magnetar can interfere with our atmosphere. In this video, you'll learn
what a magnetar is,
how it forms, and why it's considered one of the most dangerous stars in the universe.
Let's get started.
A neutron star is what's left after a very large star explodes in a supernova. Even though it has a mass similar to that of the Sun, it's extremely small, only 10 to 20 kilometers in radius. For comparison, the Sun has a radius of about 695,000 kilometers. This means a neutron star is incredibly dense. A single spoonful of its material would weigh as much as 900 Egyptian pyramids. It spins very fast and has a powerful magnetic field. Within the category of neutron stars, there is an even more impressive type, the magnetar, the main topic of this video. A magnetar is a special type of neutron star. It has an extremely strong magnetic field, the most powerful in the known universe. To give you an idea, a magnetar's magnetic field can be 100 trillion times stronger than the Sun's. Even from thousands of light years away, a magnetar explosion can affect Earth. If you were hundreds of thousands of kilometers away from a magnetar, your credit cards would stop working, just because of the magnetic field. Fortunately, magnetars are very rare. Only 1 in every 10 neutron stars becomes a magnetar. A magnetar is born when a very massive star, about 40 times the mass of the Sun, reaches the end of its life and explodes in a supernova. This explosion scatters matter in all directions. What remains is the core of the star, which collapses under immense pressure. That pressure transforms the particles into neutrons and creates an extremely dense and compact neutron star. If the conditions are just right, with specific temperature and rotation, the dynamo effect occurs. That's when the energy from heat and rotation is converted into an incredibly powerful magnetic field. And that's how a magnetar is born. When a star explodes and shrinks to become a neutron star, it starts spinning much faster. This happens because of the law of conservation of angular momentum. It's the same effect as when someone spins in a chair with their arms outstretched and spins faster when they pull their arms in. It's the same with a magnetar. As it contracts, it spins hundreds of times per second. This rapid rotation helps to further increase its magnetic field. In other words, the smaller and faster it spins, the more powerful the magnetar becomes. The magnetic field of a magnetar is simply absurd. While a refrigerator magnet has about 0.01 Tesla and an MRI machine uses around 7 Teslas, a magnetar's magnetic field can reach 10 superscript 1 Teslas. That's 100 billion times stronger. This magnetism is so powerful that, even from a distance, it could destroy any electronic device. The force is so intense that the magnetic field itself affects the magnetar's rotation, causing it to slow down over time. That's why, despite being so powerful, a magnetar has a short lifespan. A magnetar may be incredibly powerful, but it doesn't live long. Its lifespan is about 100,000 years, which, in cosmic terms, is quite short. This happens because its magnetic field is so intense that it quickly slows down its rotation, reducing its energy and activity. Over time, it loses strength and becomes an ordinary common neutron star. Even so, during its active phase, a magnetar can cause violent explosions that release more energy than the Sun does in thousands of years. It's a cosmic monster, bright, powerful, and destructive, but short-lived. Magnetars can experience something similar to earthquakes, but in space. These events are called starquakes. They occur when the magnetic field shifts and cracks the star's crust, releasing an absurd amount of energy. A single explosion can release, in just 0.1 seconds, the same amount of energy the Sun emits in an entire year. These eruptions are so violent that they've been detected from Earth, even when the magnetar was 50,000 light-years away.
It's as if the universe flashes a super bright light in the middle of the darkness. All because of a single magnetar.
Currently, scientists have identified 23 confirmed magnetars and 6 potential candidates. But it's believed that there are around 30,000 similar neutron stars just in our galaxy. Some of these magnetars are given names like SGR, soft gamma repeaters, and American Express, anomalous X-ray pulsars. At first, they were thought to be different objects, but today we know they belong to the same category. These names help astronomers understand the behavior and origin of these extreme stars. In 2004, a magnetar called GRB 1806-20, also known as SGR 1806-20, released one of the most intense explosions ever recorded. Even though it was 50,000 light-years away, the light from the explosion reached Earth's atmosphere and shone brighter than the full moon for a few moments. The energy released was equivalent to 150,000 years of solar energy, all in a single eruption. This explosion was caused by a starquake, showing the destructive and awe-inspiring power a magnetar can have, even from a great distance. Luckily, it's very far away, and let's hope it stays that way. Magnetars are small, dense, and incredibly powerful stars. Their magnetic field is the strongest in the universe, capable of affecting objects even thousands of kilometers away. Despite that, they are rare, short-lived, and fortunately, very far from Earth. We don't need to worry about them, but understanding how they work helps us better understand the extremes of the universe. And who knows, maybe even inspire a great science fiction movie.